Hi, I'm Brandon Massoni, and I'm going to talk about nickel alloys. And what's shown here in this picture on our left is nitinol, which is a nickel titanium alloy. So I'm actually going to talk about two different nickel alloys, and I'm going to go through one of them at a time. So the first one I'm going to look at is nickel aluminide, and this is a very strong and hard material, and it performs well at high temperatures. So what it's generally used for is coatings in jet engines, or it's used in furnaces, so some high temperature applications. And the picture there I don't think is an additive process. It is not an additive manufacturing process. So here's some of the material properties, and this is what I could find. On the left is the yield strength compared to the temperature, and there's a few different nickel aluminides that those are different crystal structures that it's showing there, but generally you can see it's about 800 megapascals. And so then compared to the powder properties, at least for yield strength, you have similar yield strength properties with the powder. And so the vendor for both nickel alloys that I'm going to talk to you about is Reed. They have locations in the United States, and the composition there is the aluminum 11.3%. That composition is for nickel aluminide. But they also sell the nitinol powder, which I'll talk about later. So the first research study I have talks about vapor deposition of platinum alloyed nickel aluminum coatings. So normally they would use nickel aluminide, but this study also adds platinum in there, and it's using this directed vapor deposition system, which is a little different than any of the methods we've talked about so far, in that you actually have a vapor created from the nickel aluminide platinum composition that you're using to coat. So there's an electron beam that heats it up. So it is hot. What they're comparing this to is a traditional nickel aluminide coating, and what they saw was it actually does a little bit better. So this graph on the left is the bond coat deposited, just a comparison of the peaks, and so it did a little bit better than the traditional. And then so there's some of the blown up images of the microstructure of the coating. And so the takeaway from this was that the coating with a single beta phase structure and no surface contamination. So it provided a good coating with this process. And the second material I'm going to look at or talk about is nitinol. It's a nickel titanium alloy that's about 50% weight each. And it's known as a shape memory alloy. It has a super elasticity, which means it's 10 to 30 times more elastic compared to ordinary metals. And it's biocompatible and MRI compatible. So some typical applications for this are dental braces, high-end dental braces, I guess. I don't know what a high-end dental brace is, but you can get cheaper dental braces as well. Orthopedics, trauma recovery, stents, smart stents, I guess is what's shown down in there in the bottom left-hand corner. This entire company's nitinol company makes these stents, these smart stents. So they change with the heating their shape. So some nitinol material properties. So the traditional properties are up top there, and then the additive manufacturing process material properties are in this paper that I wasn't able to access, but I identified it, and that's what the paper's about, is comparing the two properties. And so this research study is on direct selective laser melting of nitinol powder, and they took a 2-zone SLM machine, and they were producing full density nitinol 55, which means 55% titanium, and then they're preheating it to 500 degrees Celsius, and then they have scan velocities from 100 to 160 millimeters per second. And so what they were really just checking is if nitinol can be successfully printed. along with another material that I found, nickel tungsten. It's just on the fringe of being additively manufactured, and so both this paper and the one on nickel tungsten were really just proving that you could print the material. So in this case, yes, it can be printed with a good weight percent ratio, because it can change a little bit in there. Can't really see what it says. And then so the micro hardness values were 1.5 to 2 times greater than cast properties. And so here's my references.